Hello everyone. The purpose of this video is to direct you to the important points you need to focus on and also to direct you to the points that you need to ignore at this point of the course. Many of those points might be details that we are going to cover later when you take general chemistry course. But for this introduction course, we need the basic understanding of the properties of solids and liquids. So let's go over each section of this week lessons and talk about the points that you need to focus on and the points that you need to ignore. On the chapter introduction, we are going to go over every point here. This is important, and this set the foundation for this chapter. On the intermolecular forces section, we are going to learn about the different intermolecular forces that impact the boiling point, the melting point, and other physical properties of the matter. And it's very important to distinguish between intermolecular forces and intramolecular forces. One of them has to do with the forces within molecules, that's the intramolecular forces, while intermolecular forces has to do with the forces between molecules, not within molecules. So the dispersion forces, you need to know that it's a temporary force, and that's the bigger the molecule, the bigger the dispersion forces. A dipole-dipole force, you need to know that it's between polar covalent molecules, and the higher the polarity, the stronger the force, and you don't need to know much about polarity in this course. Then hydrogen bonding is a special case of dipole-dipole force. The difference, it includes hydrogen bonded to either nitrogen, oxygen, or fluorine. And you should know, of course, that the strongest among them is the hydrogen bonding. It's stronger than dipole-dipole and stronger than the dispersion forces. You don't have to worry about questions that goes into details such as number 5 and 6 here, 7 or 8. Just the basic understanding that there are intermolecular forces between molecules and that those forces will determine physical properties related to boiling point, melting point, and other physical properties. Now on the third section, phase transitions, melting, boiling, and subliming, we are going to focus on the first learning objective, which is describe what happens during a phase change, while we are going to ignore calculating the energy change. So this part is not required. So any mathematical calculations you should ignore while focusing on the concepts instead. So you need to know terms like melting, solidification, what is melting point, those definitions, but don't worry about any mathematical calculations. The same as here, you need to know the boiling, the meaning of boiling or vaporization, condensation, boiling point, what is normal boiling point. Don't worry about the enthalpy of vaporization, and don't worry about any problem that involve calculations. You need to know, however, how energy changes when matter goes from one phase to another. Does it require to absorb energy or give up energy? Also, you need to know about all phase changes terminologies such as sublimation, deposition. Again, you don't need to know about the enthalpy of sublimation. You just need to know whether the matter will give up energy or absorb energy during the change from one phase to another. For example, from solid to liquid, is it going to absorb energy to go through the phase change, or is it going to give up energy? And you can answer those questions here from 1 to 4. Don't worry about any questions that involve calculations such as 5, 6, 7, or 8. Okay, on the fourth section, properties of liquids. In this section, we are going to define vapor pressure of liquids and explain the origin of both surface tension and capillary action. And in both of those objectives, we are going to focus on the qualitative aspect, not the quantitative aspect. Meaning you need to know definition and the concept, but you don't need to worry about numbers and calculations. So you need to know the difference between evaporation and boiling, and you need to know the meaning of equilibrium when it talks about measuring the vapor pressure at equilibrium. Equilibrium has to do with the rate at which the vapor is transforming to liquid being equal to the rate at which the liquid is transforming to vapor. You don't need to worry a lot about this graph. You just need to know that the higher the intermolecular forces, the lower the vapor pressure of liquids. And you need to know about the physical property of surface tension that is related to the intermolecular forces and the capillary action and its relation to the intermolecular forces, as well as the meaning or the definition of meniscus and why water form this concave surface while mercury forms this convex surface inside glass containers, and why water beads form up on the surface of certain materials. Make sure you understand the takeaway concepts here. On those questions, again, focus on the qualitative questions like from 1 to 4 here, and don't worry about any quantitative questions such as 5, 6, and 7 or 8. 9 is a good question, and those all are qualitative questions. So 9, 10, 11, and 12. Make sure you know how to answer those questions in a qualitative fashion without going into quantitative detail. Okay, on the last section here, solids, you will focus on those learning objectives qualitatively without going into the quantitative aspects of mathematical calculations and numbers. So here make sure to read about the properties of solids and the different types of solids and the difference between the general characteristics of each one and how they differ without going into the detail, just the basic concepts. So the question like this one you should be able to answer, but you don't have to worry about question that goes into more details, such as this question here with the chemical structure, more complicated. Also try to learn about the food and the rocks that we eat, and make sure you know those concepts, the takeaway concepts, such as solids can be divided into amorphous solids and crystalline solids, and the crystalline solids can be divided into subcategories such as ionic, molecular, covalent, or metallic solid. And then you need to know the answer to those questions that are general questions. For more detailed questions such as 12, 13, and 14, you don't have to worry about those questions at the end. I hope you found this video educational. Let me know if you have any questions.